Hello everyone, this is Ankit from Kailasha Foundation Fun and Learn portal, and today we will study number system in this video. Okay, number system is one of the most important chapters in CAT syllabus, and it is obviously important in other competitive exams also because based on this chapter there are many problems intermixed in other chapters. Okay, so number system must be studied carefully. Number system, let us start from numbers. So types of numbers are natural numbers. Natural numbers are basically counting numbers. The numbers which we naturally use for counting, for example, there are five objects here. Okay, so when we start counting, we start from 1, 2, 3, 4, 5. We don't start from 0 or we don't start from 0.5. We don't start from -2. We start from 1. Naturally, we start from 1. Okay. This is a bit bigger, so we don't say it is 2.5 or something, or this is almost half of the initial the first two spheres, first two circles, but we don't say that it is 0.5 or something. We count, when we count we simply count. Okay, so it is 1, 2, 3, 4 and 5. That's why these are natural numbers. Counting numbers are natural numbers. Thereafter we come to whole numbers. Whole numbers, when 0 is included in the list of natural numbers, the fresh list will be called the set of whole numbers. So when we say natural numbers, we say 1, 2, 3, 4, 5, up to where there's no end, so we say up to infinity. Up to infinity. And some people indicate in fact not some people, but actually it is indicated with a symbol this. Okay, and when we write whole numbers 0, 1, 2, 3, 4, 5 and so on up to infinity, so natural number is this set and whole numbers is this set. Okay, now what are the negative numbers? Negative numbers, negative numbers are numbers, the same numbers but with minus sign. For your -1, -2, -3, -4. The concept of negative numbers is that, for example, when 5 is subtracted from 4, what remains? uh, in such situations we have a need of negative numbers. Okay, so now we come to integers. Integers are basically natural numbers, natural numbers, their negatives, and 0. All these numbers are integers. Means, for the sake of simplicity, if we want to understand what actually integers are, then the numbers with no decimal places are integers. The numbers with no decimal places are integers. And 2.41 is not an integer. 3.20 is not an integer. 1.0 is an integer because it can be written as 1. Okay, so whole numbers, oh sorry, natural numbers, their negatives and 0 are collectively called integers. Okay, now we come to fractions. Non-integers are basically fractions. Fractions can be written in two ways. Simple, the initial concept of fraction a by b or decimal fractions. Okay, fractions can be written in two ways, a by b or decimal fractions. But there is another type of fraction, that is mixed fraction, a b by c. Many people pronounce it in different ways, but I read it as a plus b by c. Okay, to avoid any kind of confusion, I read it as a plus b by c whenever it is written like this. uh, if you are a cat ssc or any competitive exam aspirant, I hope you must know that this expression is actually a into c plus b, that is ac plus b by c, which you can get from here also. LCM you take c, because here is 1, so AC plus B. Okay, so okay, so fractions, mixed fractions, decimal fractions. Okay, in fact integers can also be expressed as fractions. Integers can also be expressed as fractions. Okay, integers can also be expressed as fractions. Why, how? For example, we have 5. 5 can be written as 5 by 1. Okay, minus 2 can be written as minus 2 by 1. So integers can also be expressed as fractions. Okay, now uh, natural number, whole number, integer, fractions, decimals. Decimals, when we study decimals, we automatically come to a topic, recurring decimals. Recurring decimals and their fractional forms. Okay, for example, 2.3, this, it can also be written as 2.3333 and so on. Okay, what is this? It is a recurring decimal. Okay, recurring decimal are those in which a particular digit or set of digits start repeating after decimal, start repeating and never stop. Okay, so that is a recurring decimal. Never stop, that means the number of decimal places are infinite. Okay, so now it is the need of the hour that I must tell you what infinity is. Okay, so it is here when you will understand what infinity is. Uh, Around in class 8th or ninth or 10th, somewhat there, uh, you were told that 1 by 0 is equal to infinity, and later you realized after coming in class 10th or actually 12th that 1 by 0 is actually not defined. So which of one is which one of these is true? This is true or this is true? This is the question. So I must tell you this is wrong, this is true, this is correct. How, sir? But we were told 1 by 0 is infinity. The significance of negative numbers when you were younger, The significance of negative numbers was not much, and when they said 1 by 0, that means 1 by a very small number, negligible, almost 0, and infinity is a very high number. By definition, 1 by almost 0 is very high, that is infinity, and 1 by very high, that is infinity, is 0. Okay, 1 by infinity is 0 is the definition. By infinity is 0 is the definition, but 1 by 0 is not infinity. When when we are on the positive side of 0, for example 1 by 0.00000001, somewhat something like that, then we get a number very high, as high as 10000000000. Okay, 1 2 3 4 5 6 7 8 9, 1 2 3 4 5 6 7 8 9. Okay, so this number is very high for you. When you are talking about 1 2 3 4 10 20 25, then this number is very high for you. If we are talking in crores or billions or trillions, then this number is not so high. Okay, so obviously in mathematics and physics these are relative subjects, but for the sake of simplicity, let us understand this in a very simple manner, that 1 by a very small number gives a very high number. So if we reach 0, that means almost 0, then it will be infinity. Okay, but we must be on the positive side, because if we put a minus sign here, then we will have a minus sign here as well. That means 1 by 0 on the boundary we get nothing. If we are slightly on the positive side, we get plus infinity. If we are slightly on the negative side, we get minus infinity. So what exactly is at 0? Nothing. That's why 1 by 0 is not defined. 1 by 0 is not defined. 1 by 0 is equal to infinity was a simple concept which was actually wrong, which was taught to you in childhood. It was not written anywhere in your course book if it was NCERT, but it was taught to you by your teacher. And but we cannot say that your teacher was very wrong. He wanted to give you this concept that 1 by 0 on the positive side is plus infinity, and if we are slightly on the negative side, then we get minus infinity. Okay, so 1 by 0 is not defined, but 1 by infinity is defined, and it is equal to 0. So 1 by 0 is infinity is also not defined, sir. What is the difference between these two? No, 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 no. Infinity is defined. Infinity is clearly defined. So what is the definition of infinity? A value so high that we cannot achieve is called infinity. A value so high that we cannot achieve is infinity. Yes, a value so high that we cannot achieve. Now I will tell you another very interesting concept, that infinity minus infinity is not equal to 0. What is this? Infinity minus infinity is not equal to 5 minus 5 is 0, a minus a is 0, b minus b is 0, 2 minus 2 is 0. Why infinity minus infinity is not 0? Infinity minus infinity can be 0, but it is not sure. Infinity minus infinity is actually cannot be determined, cannot be determined by just looking at infinity. Infinity minus infinity cannot be determined. How? Because I just told you infinity is a value so high that it cannot be achieved. For example, there's a beggar on the street, and 5,000 rupees for him is infinity. 5,000 rupees for him is infinity. Then what will you say about 5 lakh rupees? That's also infinity. 5,000 rupees is infinity for him, then 5 lakh is obviously infinity. Now you tell me infinity minus infinity is what? 5,000 minus 5 lakh, or 5 lakh minus 5,000, or 5,000 minus 5,000. Every time you get a different answer, then how can you be so sure that infinity minus infinity is zero? It is not definite, so it cannot be determined. Something which is not definite, we say that it cannot be determined. Okay, infinity minus infinity cannot be determined. So if infinity is not definite, how can you say it is defined? You just said that infinity is defined because it has a very clear definition, and something defined means that it has a definition. So infinity has a definition, it is defined. Let us list the points. Infinity minus infinity cannot be determined. Infinity is defined. Infinity is a value so high that cannot be achieved. 1 by 0 is infinity is wrong. 1 by 0 is actually not defined. 1 by infinity equal to 0 is correct. Okay, so here we learnt about infinity. Now, recurring decimals and their fractional forms. So 2.3 recurring. 2.3 recurring. Okay, that means 2.33333 infinite times. Infinite places of decimal. Okay, infinite places of decimal. So how can we express this number in fraction? X is equal to 2.3 recurring, that is 2.3333, so on, infinite times. Okay, when we multiply both sides by 10, we get 10x is equal to, you see, you learn one thing must be very clear to you, that whenever we multiply a decimal by 10, whenever we multiply a decimal by 10, decimal shifts right side one place. We multiply by 100, decimal shifts right side by two places. We multiply by 1,000, decimal shifts three places. Okay, and when we divide, uh, the side becomes left. Okay, so 10x is equal to 23.333. So can't we write another 3 here? Yes, of course. It is still infinite places of this, sir. It is infinite minus 1. Okay. So I tell you that go to an ocean and take a bucket and uh, mm, take one bucket water out of the ocean. Okay. What will be the result? The ocean still remains the ocean. There's no change at all. You must understand that infinity minus 1 is infinity. In fact, infinity minus 5 is also infinity. Infinity minus 5,000 is also infinity, because 5,000 is a definite number. 1 is a definite number. 1 is a finite. 1 is finite. You know about 1. You just counted 1. You know about 5,000, okay, but you're not sure about infinity, what actually infinity is. So infinity minus something finite is infinity again, okay. So we can write 3 3 3 3 4 times or 5 times, as many times as we wish here, okay. For the sake of simplicity, we were getting this, we just wrote another 3 here because obviously there's a 3, because these 3's are infinite times, okay. Now equation 1 and 2, 10x, we subtract 1 from 2, so 10x minus x is equal to 23.3333 and so on, minus 2.3333. Look at this part, this is the same, it becomes 0, it becomes 21, 9x is equal to 21, cancelled out 3, 7, so sorry, x is equal to 7 upon 3, okay. So this is how you solve recurring decimals. Now 2.47 recurring. 47 recurring means 2.47474747 and so on. This is x. 10x will be 24.7474747. It will be weird because decimal is between 4 and 7. So instead of 10x, we get 100x. We multiply it by 100. Okay. 100x, decimal shifts 2 places, 247.474747. Can we write another 47? Yes. Okay. X is equal to this, 100x equal to this. So when we subtract, 99x will be equal to, this part is same, so it will be cancelled out. 247 minus 2, that is 245. Okay, so x will be equal to 245 by 99. Take another problem, x is equal to 7.123 recurring. There is no recurring sign on 1, so at first we do 10x is equal to 71.23 recurring. That is actually 71.23232323. Okay. Now we multiply by 100 again, so it becomes 1000x is equal to 7123.232323. Okay. We can write another 23. Yes. Now we subtract, so 990 x is equal to, this part is same, so cancelled out. 3 minus 1, that is 2, 5 and 7, that is 12, 7052. 7052, okay, x is equal to 7052 upon 990. You can cancel out the common coefficients, okay. Mm. So this is how you evaluate recurring decimals. Now let us see 1.9 recurring, or let's say 0.9 recurring. 0.9 recurring, what is this? X is equal to 0.99999 and so on. Tell me one thing, is it less than 1 or equal to 1 or greater than? Sir, obviously it is not greater than 1, but so it is less than 1. How? Are you sure it is less than 1? Are you sure it is less than 1? Let us see. X is equal to 0.9 recurring. Now 10x will be equal to, decimal will shift one place, 9.9999. We can write another 9. Yes. When we subtract, 9x is equal to, this part is common and cancelled, so 9 and 9 cancelled, x is equal to 1. How's this possible? Yes, it is possible because it is in front of you. Let us understand one thing, that the real numbers or rational numbers, rational numbers and irrational numbers together make the set of real numbers, and in between two different real numbers you can insert as many real numbers as you wish. Okay, so let us take that this 0.9 recurring and 1, these are two different numbers. Okay, if you don't agree with me, then okay, you are right. So let us take these are two different numbers. If these are two different numbers, there must be infinite real numbers between these two numbers. Okay, tell me one real number. If there are infinite real numbers between these two numbers, just tell me one real number. Just tell me one real number you know between these two numbers. You will just realize that you can't, because there is not. Why so? Because these two are identical. 0.9 recurring is conceptually equal to, by definition, it is equal to 1. If you Google 0.9 recurring, then you will get a page on Wikipedia. In the search results, you will get a page on Wikipedia. There are 15 or 16 explanations why 0.9 recurring is equal to 1. Okay, so this was one of those explanations how 0.9 recurring is equal to 1. So in this lecture we learnt about recurring decimals, and we learnt about infinity. Now we just learnt naturals, whole numbers, integers, fractions, decimals, recurring decimals, terminating decimals. Recurring means those decimals which don't stop, they keep repeating. Okay, terminating decimals which terminate after a few digits, after a few decimal places. There is a third category, neither terminating nor recurring decimals. Okay, these four are rationals. These two are rationals again. This one is irrational number. So what kind of decimals are neither terminating nor recurring? Can you give an example? Yes, 1.511151115111. So there's a pattern, but pattern doesn't matter. The part must repeat itself exactly. 51 is not repeating. After 51 there is 51, but there is 1 again. So there is no repetition of 51. Okay, so it is not recurring, that is, it is not repeating, and also it is not terminating. It goes on and on. So it is irrational number. Root 2 is an irrational number. Irrational number. 1 minute. Number. Root 3 is an irrational number. Root 4 is not. Why? Because root 4 is equal to 2, that is rational. Okay, pi is an irrational number. And when we consider all these numbers together, rationals and irrationals. All numbers are of two types only, rationals and irrational. When we combine both, then we get the complete set of real numbers. Okay, what is 0? 0 is a rational number. 0 is a rational number, yes, because there is no such case in 0. For a number to be irrational, there must be neither terminating nor recurring decimal. For a number to be irrational, to remember irrational number in the simplest way, this definition you must keep in your mind that for a number to be irrational, it must be neither terminating nor recurring decimal. For a number to be irrational, it must be neither terminating nor recurring decimals. All other numbers are rational numbers. Yes, forget that definition which you were taught in class 9th or class 10th, that a number of the form p by q, where p and q are integers and q is not equal to 0. Yes, that definition is correct, but for understanding, for better understanding, for precise and clear understanding, you must know this definition what I am telling you. A number that is neither terminating nor recurring decimal is irrational, and all other numbers which we know are rationals. Okay, all other numbers which we know, that is up to class 10th, whatever numbers we have seen, be it pi or be it root 2, whatever, because we didn't see imaginary numbers till class 10. Okay, so I'm talking about the syllabus up to standard 10, that whatever number you have seen, the numbers of this kind are irrationals and all other numbers are rationals. Okay, you can blindly trust on this definition. If you consider the syllabus up to class 10th, then you can blindly trust on this definition that a number neither terminating nor recurring decimal is irrational and all other numbers are rationals. Okay, so real numbers can be shown on real number line 0, 1, 2, just like we were showing integers. We can show real numbers also. For example, we have to show 2.3, then we will do 10 divisions here, and here, so somewhat here we will get 2.3. If we have to show 2.31, then between 2.3 and 2.4 we will again divide it 10 times and we will show 2.31. Okay, it depends upon the scale we have. We can depict a real number on a number line. Okay, there are ways to represent irrational numbers on number line also. There are ways to represent recurring decimals on number line also. Okay, so real numbers can be presented on number line. Real numbers are negatives, positives, zero, decimals, recurring decimals, non-recurring decimals, terminating, non-terminating, all kinds of decimals are real numbers. Okay, and between any two real numbers, for example 2.31 and 2.305, we can place as many real numbers as we wish. For example 2.306, 2.307, 2.308, all these numbers are between these two. Less than 2.31 and greater than 2.305, these numbers are. Okay, so these can be placed between these two numbers. Between two different real numbers, we can place as many real numbers as we wish. Sir, these are just 3-4 numbers. What if we have to place 100 numbers between these two? Then we can do 2.305001, 2.305002, 2.305003. You can see we can place a few thousand numbers like this. Okay, so there is no limit for placing real numbers between two different real numbers. Okay, now imaginary numbers, the numbers which are not real are imaginary, uh, which you need not know, but we will discuss those also a bit. For example, there is no square root of -1, there is no real square root of minus 1. For example, when you studied quadratic equation, you were getting a phrase many times, no real roots. If no real roots, then what kind of roots? Imaginary roots. That were imaginary. A number with negative sign cannot be, cannot have a square root, cannot have a real square root. Okay, so for the minus part, we put an I here, and the remaining is this root 1. Root 1 is 1. So 1 into I, that is I. For example, minus 4, so root 4 is 2, and for the minus part we put an I here. So 2i. It is actually called iota. It is a Greek alphabet, but it resembles our English alphabet I. So for the sake of simplicity, we call it I. Okay. And root of minus 9, that will be 3i, and so on. Okay. So these are not in your syllabus, but I just told you to give you an idea what actually imaginary is. Okay, something which is not real is imaginary. Now, types of real are rational and irrational, I told you, and fractions, mixed fraction. So there are types of fractions. Fractions, this I missed. Fractions, proper, improper, and mixed. Okay, 2 by 5, 3 by 11, 5 by 2, 8 by 3, 3 1 by 7, 3 1 by 5, 7 1 by 3. Okay, these are mixed fractions. Why this is proper fraction? The numerator, the upper part, that is called numerator is lesser than denominator. The numerator is lesser than denominator is proper fraction. Okay, numerator is greater than denominator, that is improper fraction. Okay, so what if numerator is equal to denominator? That will also be improper, but actually that is not a fraction, that is represented as a fraction. For example, 5 by 5, actually it is 1 and not a fraction, it is represented as a fraction. That will fall in the improper category. Okay, mixed fractions are these. This is actually equal to 3 5s are 15 and 1, that is 16 upon 5, and 7 3s are 21 plus 1 22 by 3. These are improper fractions expressed as mixed fractions. Okay, a mixed fraction is a converted form of improper fraction. Type of integers: integers are whole numbers, real numbers, okay, negative numbers. Now there is another kind of classification of numbers, that is even and odd. Even and odd, when we talk about even and odd, we are talking only about integers. Only integers can be even or odd. Okay, so even means divisible by 2, odd means not divisible by 2. A few students had confusions in the last batch. Sir, are the negative numbers divisible by? Yes, minus 4 is divisible by 2. Minus sign doesn't affect divisibility. Okay, so keep that in mind. Minus sign doesn't affect divisibility. If 4 is divisible by 2, then minus 4 is also divisible by 2. Okay, uh, now I will clear a few doubts about 0. 0. 0 by anything, anything non-zero is equal to 0. Anything non-zero by 0 is not defined. 0 upon 0 is not defined or cannot be determined. Okay, 0 is divisible by every number. Every number except itself. 0 is divisible by every number except itself. 0 cannot divide any number. 0 can't divide any number. Okay. 0 is divisible by every number, so 0 is divisible by 2 also. If 0 is divisible by 2, then 0 is even. Yes. 0 is even. For the sake of simplicity, we can understand a number ending in 2, 4, 6, 8 or 0 is an even number. Okay. Whenever we talk about even and odd, those must be integers. That means there must be no decimal places. That means a number without decimal places ending in 2, 4, 6, 8 or 0 is even. A number without decimal places ending in 2, 4, 6, 8 or 0 is even. And the numbers without decimal places ending in 1, 3, 5, 7 and 9 are odd. Okay. Uh, now we have also talked about recurring decimals, 0.9 recurring. Okay. In the next lecture, we will learn about prime and composite numbers. Bodmer's rules, indices, divisibility. And in further lectures, we will study unit digit problems, last 2-digit problems, remainders, base system, and factorials and miscellaneous problems. Okay. LCM, HCF also. Yes. So thanks for watching this video. Don't forget to like, share and subscribe. Thank you so much. Happy learning. Bye bye.